Python syntax. Python syntax refers to the set of rules that defines how a Python program is written and interpreted by both the machine and programmers. Python is known for its clear, readable, and concise syntax, making it an excellent language for beginners. In this example, we'll look at a simple program that prints "Hello World" to the console. In this piece of code, print is a function that Python provides to display output to the console. The text, "Hello World," is a string enclosed in single quotes. When the Python interpreter runs this code, it executes the print function and passes the string "Hello World" as an argument, which then gets displayed on the screen. This example highlights the simplicity and readability of Python syntax, requiring very few lines of code to perform basic operations. Data types and variables. In Python, variables are used to store information that can be manipulated or used throughout your program. A data type specifies the kind of value a variable can hold, such as numbers, text, lists, tuples, dictionaries, etc. Understanding data types and variables are crucial for data manipulation and basic Python operations. In this code snippet, name is a variable of the string data type holding text John Doe. Age is an integer data type holding number 30 without decimals. Height is a float data type with a decimal value of 5.11 representing height. IsStudent is a Boolean data type holding either true or false, in this case false. Each variable is assigned a value using the equals operator, introducing the concept of variables as named locations for data storage. Control structures, if statements, loops. Control structures guide the flow of execution in a program. If statements help make decisions based on conditions. Loops, such as for and while, repeat actions until a condition changes. Understanding these is crucial for task automation. The if statement checks if temperature is greater than 30. If true, it prints "it's hot outside." Otherwise, it prints "the temperature is pleasant." The for loop iterates over a sequence generated by range 5, starting from 0 up to but not including 5, printing each number. This illustrates deciding based on a condition with if-else and repeating actions with a for loop. Functions, definition and scope. In Python, functions are reusable blocks of code that perform specific tasks. Defining functions helps in making our code organized and manageable. The scope of variables in functions determines where these variables can be accessed from within the code. In this example, the function greet is defined to accept one parameter, name. Inside the function, a local variable message is created by concatenating hello with the name. The function then returns the message. When we call greet with the argument Alice, it prints "Hello Alice." The variable message has a local scope within the function, meaning it can't be accessed outside of greet. Modules and packages. In Python, a module is a file containing Python definitions and statements. The file name is the module name with the suffix .py added. Modules can define functions, classes, and variables that you can use in other Python scripts. In this example, we first import the math module, which is a collection of mathematical functions and constants. Then, we use the squart function from the math module to calculate the square root of 16. The syntax import module name is used to make the module's functions available in your script. Virtual environments. Virtual environments in Python are isolated environments that allow you to manage packages and dependencies for individual projects separately. This ensures that projects do not interfere with each other and helps in maintaining dependencies organized and consistent. By using virtual environments, you can easily manage different versions of packages for different projects without conflicts. The code shown consists of 2 lines. The first line creates a new virtual environment named myprojectenv in your current directory using the module venv, which is a standard Python library for creating virtual environments. The second line activates the virtual environment on Unix, Linux systems. Activating the environment adjusts the path so that the Python interpreter and installed packages in the virtual environment have precedence over the system-wide Python installation. This ensures that when you install new packages, they are installed in the virtual environment. On Windows, you would use myprojectenv/scripts activate instead. Error and exception handling. Error handling is crucial in programming to manage unexpected issues in code. Python uses a try-except block to catch and handle exceptions, ensuring the program can gracefully deal with errors. This snippet demonstrates basic error handling in Python. The try block contains code that might throw exceptions. If a user inputs something that's not a number, a value error is caught, and a friendly message is printed. A division by 0 attempts raises a zero division error, also caught separately. The finally block runs regardless of exceptions, indicating an attempt to divide was made. This structure helps in making robust programs that can handle input errors gracefully. Reading from and writing to files. Interacting with files is a core feature of any programming language, enabling the storage, retrieval, and manipulation of data. In Python, this is achieved through built-in functions that allow us to open a file, read its content, or write new content to it. It's important to remember to close the file afterward to free up resources. This snippet demonstrates writing to and reading from a file named example.txt. The with statement ensures the file is properly closed after its sweep finishes. In the writing section, W signifies write mode, where hello world is written to the file. If example.txt doesn't exist, Python creates it. In the reading section, R signifies read mode, where the content of example.txt is read into the variable content and then printed. This is a basic example of file handling in Python. Working with different file formats, TXT, CSV, JSON, etc., understanding how to manipulate various file formats is essential. Here we'll demonstrate how to read and write to TXT, CSV, and JSON files, which are among the most common formats you'll encounter. For TXT files, we use open with the W mode to write a simple string. This mode will create the file if it doesn't exist or overwrite it. For CSV files, the CSV module facilitates writing rows of data, starting with column headers. We open the file with W mode and use a csv.writer object for writing. New line equals is specified to prevent adding an extra new line in Windows. For JSON files, the JSON module's dump function allows us to write a dictionary to a file in JSON format, which is great for structured data storage. Each of these approaches is tailored to the specific data structure and requirements of the file format being worked with. File paths, absolute versus relative paths. Understanding file paths, both absolute and relative, is crucial when automating tasks that involve file management. An absolute path is the complete path from the root of the file system to the file, making it independent of the current working directory. A relative path, on the other hand, specifies the file location in relation to the current working directory. The code first imports the OS module, which provides functions for interacting with the operating system. It then defines an absolute path that specifies the complete path from the root to a file named report.txt. For relative path, it defines a path that assumes the current working directory is /user_example/, leading to the same file using a path relative to this directory. By utilizing os.getCwd, we get the current working directory. We then use os.path.join to combine this current directory with the relative path, forming an absolute path equivalent to abs path. This demonstrates converting a relative path to an absolute one based on the current working directory. Creating, listing, and deleting directories. Python's OS module allows you to interact with the file system. Creating directories is a common task in automating file management. The code imports the OS module, which contains the makeDARS function. This function creates a new directory named new directory and a subdirectory within it named subdirectory. The exist_OK parameter is set to true, which means the function will not raise an error if the directory already exists. OS and shootil modules. The OS and shootil modules in Python provide functions to interact with the file system. Using these modules, you can perform operations like creating directories, listing contents of directories, copying or moving files, and more. Here, we will see how to use these modules for common file and directory tasks. This code demonstrates the basic usage of the OS and shootil modules. First, we import these modules. Then, we create a new directory named new directory using os.mkdir. Next, we copy a file named source.txt to new directory and rename it to destination.txt using shootil.copy. To see what's inside new directory, we use os.listdir, which returns a list of its contents. Finally, we remove new directory and all its contents using shootil.rmtree, demonstrating how to clean up. Introduction to web scraping. Web scraping involves the process of extracting information from websites. This can be useful for gathering data from the web for analysis, monitoring, or automating repetitive tasks. Python, with packages like Beautiful Soup and requests, makes web scraping accessible. This code snippet demonstrates a basic approach to web scraping using Python's requests and Beautiful Soup libraries. First, the requests.get URL function fetches the HTML content of the specified URL. Then, Beautiful Soup parses this content, creating a soup object. Soup.prettify is then used to print the formatted HTML content, making it easier to read and understand. This is a foundational technique for further extracting specific data from web pages. Working with web APIs. Web APIs allow applications to interact with the web services directly. Using Python to work with web APIs involves sending requests to the API's URL, often with some parameters, and then handling the data it responds with. This data is commonly in JSON format, making it easy to parse with Python and use within an application. This example demonstrates how to make a simple GET request to a hypothetical weather API and handle the response. This code imports the requests module, crucial for making HTTP requests. It specifies the API URL and parameters needed for the request, such as the API key and a query, Q, which in this case is London. By sending a GET request to the API with these parameters, we receive a response, which is converted into a JSON format using response.json. Finally, the code accesses and prints the current temperature in London by navigating through the JSON data. This process is fundamental when working with web APIs to fetch and utilize web-based data. Using requests module for HTTP requests. The requests module in Python is a powerful HTTP library for making HTTP requests to web servers. It simplifies the process of interacting with web services and processing the responses. In this example, we'll demonstrate how to use the requests module to send a simple GET request to a website, which is often the first step in web scraping. In the provided code snippet, we first import the requests module. Then, we use requests.get to send a GET request to https api.github.com. The GET method returns a response object, from which we extract the HTTP status code using response.statuscode to verify our request was successful, status code 200. We then print the JSON content of the response using response.json, which converts the JSON response to a Python dictionary. This is a basic example of how to interact with APIs or web pages to retrieve information using the requests module. Parsing HTML with Beautiful Soup. Beautiful Soup is a Python library designed for quickly parsing HTML and XML documents. It creates parse trees that is easy to navigate, search, and modify, which is perfect for web scraping tasks. The library handles various intricacies of the HTML format, making the extraction of data from web pages straightforward. In this code, we first import the Beautiful Soup class from the BS4 module. We then define a simple HTML document as a string, HTML score doc. This HTML document includes basic tags like HTML, head, title, and p. After defining the HTML document, we create a Beautiful Soup object by parsing the HTML document string and specifying html.parser as the parser. Finally, we call the prettify method on our Beautiful Soup object, soup, to print the HTML content in a nicely formatted way. This method is useful for understanding the structure of complicated HTML documents. Automating web browser actions with Selenium. Selenium is a powerful tool used for automating web browsers. It allows you to simulate user actions like clicking buttons, entering text, and navigating through pages programmatically. This can be especially useful for tasks that require interaction with web pages, testing web applications, or scraping data from websites. To use Selenium, you first need to install the Selenium package and a driver for your specific browser, such as Chrome driver for Google Chrome. This code first imports the WebDriver module from the Selenium package. It then initializes a new Chrome browser window. With browser.get/example.com, it navigates to a specified website. Browser.findElement by tag name button is used to find the first button element on the page, and element.click simulates a mouse click on that button. Finally, browser.quit closes the browser window. This basic example demonstrates how to automate opening a web page, interacting with an element, and closing the browser, which is foundational for more complex web automation tasks with Selenium. Handling web data formats, JSON, XML. When working with web data, you'll often encounter JSON, JavaScript object notation, and XML, extensible markup language. Both are popular formats for structuring data exchanged by web services. Python has built-in support for parsing and manipulating these formats. In this example, we use Python's built-in JSON module to parse a JSON-formatted string. The JSON.loads function is used to parse the JSON string into a Python dictionary, allowing us to access the data as we would with a typical dictionary in Python. This is a common pattern for handling JSON data, which you'll often encounter when working with APIs or web scraping. For XML, Python has modules like xml.etree.elementtree, which provides similar functionalities for parsing and manipulating XML data. Understanding how to work with these formats is crucial for web-based automation tasks. Reading and writing Excel files with OpenPixel. To work with Excel files in Python, OpenPixel is a powerful library that allows for reading, writing, and modifying .xlsx files. This makes it an excellent tool for automating tasks that involve Excel documents. In this code snippet, we start by importing the workbook class from the OpenPixel module. Then, we create a new Excel workbook instance by invoking the workbook constructor. The active property of the workbook instance gives us the default worksheet, and we assign the text "Hello OpenPixel" to cell A1 of this sheet. Finally, we save this workbook to a file named example.xlsx. This shows how to create an Excel file and write data to it using OpenPixel. Manipulating PDFs with PyPDF2. PyPDF2 is a popular Python library used for reading and manipulating PDF files. With PyPDF2, you can split, merge, rotate, and more. In this example, we'll merge two PDFs into one. This code snippet demonstrates how to merge two PDF documents into one using PyPDF2. Initially, it imports the necessary classes, PDF Reader and PDF Writer, from PyPDF2. Then, it opens both PDF files to be merged with PDF Reader. A PDF Writer object is created to hold the merged content. The for loops iterate through each page of both PDFs and add them to the Writer object. Finally, the merged content is saved to a new file, mergeddocument.pdf, using the writer's write method. This demonstrates a simple yet powerful application of manipulating PDFs with PyPDF2. Working with images using Pillow. Pillow is a powerful library in Python used for opening, manipulating, and saving many different image file formats. It's an extension of Pile, Python imaging library, and is designed to be user-friendly and efficient. In this example, we'll show how to open, display, and save an image using Pillow. In the provided code snippet, we start by importing the image module from Pile, which is the fundamental class of Pillow. We open an image named example.jpg using image.open and use the with statement to ensure the file is properly closed after its suite finishes. Within the block, calling img.show displays the image. This can be especially useful for debugging or quick checks. Finally, we save the same image in a different format, PNG, using img.save example.png. This demonstrates how straightforward it is to convert image formats with Pillow. Automating Excel with Pandas. Pandas is a powerful Python library used for data manipulation and analysis, which makes it an excellent tool for automating tasks in Excel. With Pandas, you can read, write, and manipulate Excel files with ease, enabling automation of data processing tasks. This code snippet demonstrates how to automate Excel file manipulation using Pandas. First, we import Pandas. Then we read an Excel file, example.xlsx, into a data frame, which is a primary data structure in Pandas. We process the data by adding a new column, which in this example is populated by multiplying an existing column's values by 10. Finally, we write the modified data frame to a new Excel file, modified example.xlsx, ensuring we do not include the data frame index in the output file. This showcases the simplicity and power of automating Excel with Pandas for tasks such as data processing and analysis. Data manipulation and analysis with Pandas. Pandas is a powerful Python library for data manipulation and analysis, specifically designed to work with structured data in a table format, such as Excel spreadsheets. It provides data structures and functions that make it easy to manipulate large datasets, perform complex operations, and extract insights. In this example, we'll demonstrate how to read an Excel file, perform a simple operation, and write the result back to a new Excel file. The code begins by importing the pandas library with the alias PD. A data frame, df, is created by reading data from an Excel file named sampledata.xlsx using the pd.readExcel function. A new column, total, is then added to df by multiplying the quantity and unit price columns. This effectively demonstrates how to perform column operations. Lastly, the modified data frame is written back to a new Excel file, updatedData.xlsx, without the index column using df.toExcel with index equals false, showcasing how to save changes. This simple process encapsulates reading, manipulating, and writing data, illustrating Panda's ease of use for data analysis tasks. Sending emails with SMTplib. Sending emails programmatically is a common task that can be simplified using Python's SMTplib library. It allows for easy handling of SMTP, Simple Mail Transfer Protocol actions, making it straightforward to send emails. Here, we'll focus on sending a simple email using this module. First, we import SMTplib and email message. An email message object is created to store the email content, including subject, sender, receiver, and body. We use smtplib.smtpssl to create a secure connection to the server, smtp.gmail.com. 465 is for Gmail with SSL. We then log in using the email address and password of the sender's account. Finally, smtp.sendMessage, MSG sends the email. Note that for security reasons, it's better to use environment variables or input methods to handle passwords rather than hard-coding them. Working with email templates. When automating emails, it's often helpful to use templates to maintain a consistent format for different types of emails. Python offers several ways to work with email templates. One common approach is to use the string template class from the standard library. This approach allows you to define placeholders in your template, which can be substituted with actual values at runtime, making your automated emails dynamic and flexible. In the provided code snippet, we import the template class from the string module of Python's standard library. We define email template as a multi-line string, denoted by triple quotes, with placeholders, name DOM, and order ID. These placeholders are intended to be replaced by actual values. To accomplish this, we create a template object by passing email template to template. Subsequently, we use the substitute method of the template object, replacing placeholders with real values, John Doe and 123456 in this case. The result is a personalized email content ready to be sent. This method is particularly useful for tailoring emails to individual recipients in automation scripts. Parsing and processing email content. Parsing and processing email content is crucial for automation tasks like filtering emails, extracting data, or automating responses. Python's email library provides tools to easily handle email content, making parsing a straightforward task. In the following example, we'll parse an email content, extract its body, and print it. This is particularly useful for processing incoming emails in automated workflows. In this code, we first import message from string from the email library. Email content contains raw email data. We convert this raw data into a message object using message from string. We then check if the email is multi-part. Multi-part messages have multiple parts, like attachments or HTML and plain text versions of the message. We traverse all parts with msg.walk and check their content type with getContentType. If it's text plain and not an attachment, not in CDispo, we print its payload, the content of that part, with getPayload. For non-multi-part emails, we directly print the payload. Automating email replies. Automating email replies can significantly increase efficiency, especially for repetitive email responses. Python offers libraries such as smtplib and email to streamline this process. The following example demonstrates a simple automated email reply using these libraries. In this code, we utilize the templib for SMTP protocol handling and email.mime.text mimetext for crafting the email message. We start by configuring the SMTP server details, including the server address, port, sender's email, and password. The function sendReply takes the receiver's email and message text as input. Inside the function, a MIME text object is created for the email content, and email headers, subject, from, and to are set up. We then establish a secure connection to the SMTP server using starttls, log in with the sender's credentials, and use sendMail to dispatch the email. This code represents a basic framework for sending automated email replies. Working with attachments. Dealing with email attachments is a common requirement in automation. Python's email library allows us to manage attachments in a straightforward manner. Here, we'll demonstrate how to add an attachment to an email message using the email, SMTP-plib, and MIME-based classes. The goal is to prepare, attach, and send an email with an attachment using these tools. This code snippet showcases the process of sending an email with an attachment using Python. Initially, it imports the necessary libraries. It then sets up the sender's email, password, and the recipient's email. The subject and body of the email are defined, followed by specifying the attachment file. The MIME-based class is used to create a MIME object for the attachment, which is then encoded in base64 to ensure it's correctly transmitted over email protocols. Lastly, the email is sent using SMTP protocol with TLS encryption for security. The attachment is effectively attached to the email through the part add header method, informing the email client about the attachment's presence and its name. Introduction to task scheduling. Task scheduling in Python is a technique that allows you to automate tasks at predetermined times or intervals. This is incredibly useful for routine tasks like backups, sending emails, or updating databases automatically without human intervention. Python offers various libraries to schedule tasks, but one widely used is schedule. In this code, we first import the schedule and time libraries. The job function prints a message simulating a task to be scheduled. Using schedule.everyone, minutes.job, we tell the scheduler to execute the job function every minute. The infinite loop with schedule.runPending checks and runs any scheduled tasks, and time.sleep1 pauses the loop for 1 second to prevent it from consuming too much CPU. This setup demonstrates a basic but powerful way to automate and schedule tasks in Python. Using the schedule module. The schedule module is a Python library designed to help you schedule tasks to be executed at specific times or intervals. It is more user-friendly compared to the built-in sched module. With schedule, you can run Python functions or any callable periodically at predetermined intervals. It's perfect for running background tasks or automating regular jobs in Python scripts. First, we import the schedule and time modules. We define a simple function job that prints a message. We then tell the schedule module to run job every 10 seconds using schedule.every10seconds.doJob. The while true loop along with schedule.runPending ensures that the scheduler checks and executes any pending jobs as time progresses. Time.sleep1 is used to make the loop wait for 1 second between checks to reduce CPU usage. This example demonstrates how to use the schedule module to execute a task at regular intervals. Cross-platform scheduling with cron, Linux, and Task Scheduler, Windows. For automating tasks across different platforms, cron jobs in Linux and Task Scheduler in Windows are vital tools. These allow for the execution of scripts at scheduled times without manual intervention. Cron is used in Unix-like operating systems, specifying the schedule in a crontab file. Windows Task Scheduler provides a graphical user interface for scheduling tasks. To ensure cross-platform functionality, understanding both is essential. In the Linux example, the cron job is set to run a Python script at 5 a.m. daily. The entry consists of 5 time and date fields, minute, hour, day, month, day of week, followed by the command to execute. In Windows, the PowerShell script creates a new task that runs Python with your script as its argument, also scheduled at 5 a.m. daily. It combines creating an action to determine what program to run, a trigger to define when the task should start, and finally, registers the scheduled task with a specified name. Automating script startup at boot. Automating the startup of a Python script at boot allows it to run without manual intervention when a system starts. This can be particularly useful for scripts that perform monitoring, updates, or server-related tasks. There are several ways to achieve this, depending on the operating system. Here, we'll focus on a common method for Linux systems using a crontab entry. The code snippet provided uses the cron scheduler, which is standard on most Unix-like operating systems. The @reboot directive tells cron to run the command following it every time the system starts up. In this case, the command is python path yourscript.py, which runs your Python script located at /path to yourscript.py. To apply this, you must add this line to your cron tab file, which can be accessed by running crontab-e in the terminal. This method provides an easy and flexible way to ensure your Python script runs automatically at system startup. Monitoring and logging script activities. Monitoring and logging script activities is essential for understanding how your automated tasks perform over time. It allows you to track the success or failure of operations, diagnose issues, and optimize performance. Python's built-in logging module provides a flexible framework for emitting log messages from Python programs. Let's implement a basic logging setup for a script. The code snippet demonstrates basic usage of Python's logging module. First, it configures logging to write messages to a file named example.log and sets the logging level to info, meaning only info, warning, error, and critical messages will be recorded. An informational message is then logged using logging.info. In the try except block, an attempt to divide by 0 generates a 0 division error, which is caught and logged as an exception using logging.exception, including a traceback. This setup helps monitor the script's operations and identify errors. Introduction to databases. Databases are essential for storing, retrieving, and managing data efficiently. They can handle vast amounts of information and support complex querying, making them indispensable for many applications. Python interacts with databases through various libraries, such as SQLite 3 for SQLite databases, which is built into Python, making it an excellent starting point for learning about database interaction. This code showcases the basics of database interaction in Python using the SQLite 3 module. It begins with importing the SQLite 3 module, which provides a simple interface to SQLite databases. The connect function establishes a connection to the example.db database. If the database does not exist, SQLite will automatically create it. A cursor object, which allows for database interaction through SQL commands, is created using the con.cursor method. Finally, the database connection is safely closed with con.close to ensure resources are properly freed and to avoid potential data loss. Working with SQLite and Python. SQLite is a C library that provides a lightweight disk-based database. It doesn't require a separate server process, making it a popular choice for embedding in applications. Python comes with built-in support for SQLite through the SQLite 3 module, allowing you to create, query, and manage databases directly in Python. This code snippet demonstrates the basics of using SQLite in Python. First, we import the SQLite 3 module. Then, we establish a connection to an SQLite database file named example.db. If the file doesn't exist, SQLite and Python will automatically create it. Next, we create a cursor object which is used to execute SQL commands. Here, we create a table named stocks if it doesn't already exist, with columns for date, transaction type, symbol, quantity, and price. We insert a single row of data into the table representing a stock transaction. Finally, we commit the changes to the database to make sure they are saved, and then close the connection to free resources. This example provides a foundational approach to working with databases in Python. Basic SQL queries: select, insert, update, delete. In interacting with databases, the four fundamental operations are essential: select to fetch data, insert to add new records, update to modify existing records, and delete to remove records. Using these operations allows us to manage data efficiently within a database. The examples provided demonstrate these operations within the context of a fictional users table. The select statement is used to fetch all records from the users table. The insert statement adds a new record with username new user and email newyuser@example.com. The update statement modifies the email of the user with username new user to updated email@example.com. Finally, the delete statement removes the user whose username is new user from the users table. These operations form the basis of data manipulation in SQL and are crucial for database interaction. Using SQL Alchemy ORM for database interaction. SQL Alchemy is a powerful and flexible ORM, object relational mapping tool for Python, which allows for the easy and intuitive interaction with databases using Python classes and objects. It abstracts away the complexities of direct database interaction, providing a more Pythonic way of working with data. In this example, we're going to set up a simple interaction with a SQLite database. In this example, we first import necessary components from the SQL Alchemy package. We define a SQLite engine using createEngine, which points to an in-memory database for simplicity. The user class represents a table in our database, with columns for the user's ID, name, and age. The declarative base function is used to create a base class for our model classes. After defining the class, we bind our engine to a session, allowing us to interact with the database. We then create a new user instance and add it to our session. Upon committing the session, the user is persisted to the database. Lastly, we retrieve the user we just added by filtering on their name and print out their details. Connecting to and working with other DBMS, MySQL, PostgreSQL. Before you proceed, make sure you have MySQL installed on your machine and the MySQL connector Python package installed in your Python environment. You can install the connector using pip install MySQL connector Python. The following example demonstrates how to establish a connection to a MySQL database and perform a simple database operation. This code establishes a connection to a MySQL database using the mysql.connector module. Initially, it creates a connection object by passing the necessary connection parameters such as the host, user, password, and the database name. Then, it creates a cursor object, which is used to execute SQL queries. The execute method is used to run a SQL command. Here, it fetches all records from your table. The results are then fetched using the fetchAll method, and we iterate over these results to print them out. Finally, the connection is closed with con.close, which is a good practice to release database resources. Introduction to GUI automation. GUI automation allows you to control the graphical user interface, GUI, of your computer applications programmatically. This can involve clicking buttons, typing text, navigating menus, and more, all without human intervention. It's a powerful way to automate repetitive tasks on your desktop, such as filling out forms or managing files. This code snippet demonstrates a simple GUI automation task using the PyAutoGUI library. First, it imports the PyAutoGUI module, which is essential for GUI automation in Python. Then, it uses the write function to simulate typing the text "Hello World" into the currently focused text field on the screen. After that, the press function simulates pressing the Enter key. This could be useful in a situation where you want to automate typing into a text editor or a chat application. Remember, for this to work, PyAutoGUI and its dependencies must be installed on your system. Automating keyboard and mouse actions with PyAutoGUI. PyAutoGUI is a Python module used for controlling the mouse and keyboard to automate interactions with other applications. It can send virtual keystrokes and mouse clicks to applications, making it possible to automate tasks that require user input. The library comes in handy for repetitive tasks and can work on Windows, macOS, and Linux. In the provided code, import PyAutoGUI brings the PyAutoGUI library into the script, giving access to its functions. The PyAutoGUI.move to 100, 150 function moves the mouse cursor to the screen coordinates 100, 150. Following that, PyAutoGUI.click simulates a mouse click at the current cursor location. Lastly, PyAutoGUI.write Hello World interval 0.25 types out Hello World with a quarter-second delay between each character, simulating a more natural typing speed. This demonstrates basic mouse movement, clicking, and keyboard typing automation with PyAutoGUI. Creating simple GUIs with tkinter for script interaction. Tkinter is a Python library used to create graphical user interfaces, GUIs. It's a standard Python interface to the TK-GUI toolkit and is included with most Python installations. Creating simple GUIs allows users to interact with scripts through visual elements like buttons, text boxes, and labels, rather than text inputs in a console. This can make your scripts more user-friendly and accessible. In the provided code snippet, we first import the required class from the tkinter module. We then instantiate a tk-root widget, which is a window with a title bar and other decoration provided by the window manager. The root widget serves as the main window for our application. We set the window's title using the title method. Next, we create a label widget as a child to the root widget, with the text Hello Tkinter displayed. The pack method is called on the label widget to make it visible. Finally, we enter the tkinter event loop by calling root.mainLoop, which waits for events such as button clicks or key presses and updates the GUI accordingly. This simple GUI demonstrates creating a window and displaying text. Integrating scripts with desktop environments. Integrating Python scripts with desktop environments allows for automation of repetitive GUI-based tasks, such as opening files, navigating menus, and more. This involves simulating mouse clicks, keyboard presses, and other user interactions. An efficient way to accomplish this is by using the PyAutoGui library. This script uses PyAutoGui to first move the mouse cursor to the screen position 100, 100 over 1 second, and then performs a click. Next, it attempts to locate a specific application, in this case a text editor, on the screen by searching for an image, textapp.png, which should be a screenshot of the application's icon or interface. Upon finding it, the script moves the mouse to the center of this icon and clicks to open the application. This demonstrates basic interaction with desktop environments through Python for the purpose of automating tasks. Cross-platform considerations for GUI automation. When automating GUI applications, it's essential to consider the varying behaviors across different operating systems, like Windows, macOS, and Linux. This ensures your automation scripts are portable and can run on any platform without modifications. We will use PyAutoGui, a cross-platform GUI automation Python library, to illustrate handling such considerations. The code demonstrates a basic PyAutoGui task of locating and clicking a button on the screen based on an image file, button.png. The locate center on screen function looks for the image on the screen and returns the coordinates of its center. If the element is found, PyAutoGui.click clicks on the derived location. The type error is caught and handled in case the element isn't found, when locate center on screen returns none. This example shows how to handle situations that may vary across different platforms or screen resolutions, ensuring your script doesn't crash if a UI element is absent. Always ensure the images used for locating elements are captured in the environment they're intended for, to mitigate differences in appearance across platforms. Writing test cases with unit test. In Python, unit test is a testing framework that allows you to write test cases to check your code. It follows a similar methodology to XUnit frameworks found in other programming languages. Writing test cases is essential for ensuring your code behaves as expected under various conditions and makes future refactoring safer and more reliable. The code snippet defines a test case test sum that inherits from unittest.testCase, a key component for writing tests in Python with the unit test framework. Within testsum, we define a test method testsum, which checks if Python's built-in function sum returns 6 when adding 1, 2, and 3. We use assert equal to verify the function's output against the expected result. The last 2 lines check if the script is run directly, and, if so, call unittest.main, which runs all of the test methods in the file. Introduction to debugging in Python. Debugging is a crucial part of programming that involves identifying and removing errors or bugs from code. Python offers several tools and techniques for debugging, making it easier to isolate and fix issues. The primary goal is to understand what your code is actually doing, as opposed to what you believe it is doing. Let's start with a simple example, illustrating a common debugging scenario. In this code snippet, the intention is to sum 2 numbers. However, a bug is introduced by mistakenly using the multiplication operator far instead of the addition operator plus. Running this code returns 6 instead of the expected 5, indicating a logical error. Debugging involves identifying that the incorrect operator is used in the result assignment line within the add numbers function and correcting it to use plus. This is a simple example, but debugging can often involve much more complex scenarios, requiring a systematic approach to isolate and solve the issue. Logging for debugging and monitoring. Logging is a critical way to understand what's happening inside your application. It can help with both debugging during development and monitoring after deployment. Python's logging module offers a flexible framework for emitting log messages from Python programs. We use it for tracking events that happen when the software runs. The key components in logging are the loggers, handlers, formatters, and filters. This code snippet showcases how to set up basic logging. Firstly, we import the logging module. The basic config method configures the logging system with basic settings. Here we set the logging level to debug, which means all messages at this level and above will be tracked. Different methods like debug, info, warning, error, and critical are used to log messages at respective levels of severity. Adjusting the severity level impacts which messages are actually logged. Using PyTest for more advanced testing scenarios. PyTest is a powerful tool for testing Python applications, known for its simplicity and ease of use for basic tests. However, it also supports more advanced testing scenarios, such as parameterized testing, fixtures, and plugins. In this section, we'll explore how to use PyTest to conduct parameterized tests, which allow us to test a function with multiple sets of inputs easily. In the provided code, we start by importing the PyTest module, then use the @pytest.mark.parameterize decorator to define multiple sets of inputs and expected outputs for our test function, test_add. This decorator takes two arguments, a string specifying the names of the arguments to the test function, and a list of tuples, where each tuple represents a set of parameters and their corresponding expected result. The test function then executes with each set of parameters, allowing us to verify that our function works correctly with different inputs. This approach significantly increases the efficiency and coverage of our testing process. Performance profiling and optimization. Performance profiling is crucial for identifying bottlenecks in your code. Python's cProfile module is an efficient and flexible profiler that provides insights into the frequency and duration of function calls. Optimization involves restructuring code to enhance its performance without altering functionality. We'll demonstrate profiling with cProfile and a simple optimization technique. The code imports cProfile and defines example function, which computes the sum of double each numbers up to 99999. Using cProfile.run, we profile example function. The profiler outputs the number of calls, time spent in each function, and other vital statistics. This information helps identify performance bottlenecks. For instance, list comprehension can be more efficient than equivalent operations using loops. By analyzing profiler output, we can make informed decisions on where and how to optimize code, leading to improved performance without compromising functionality. Creating CLI, command line interface tools. Creating CLI tools in Python allows you to automate tasks and make programs usable from the terminal. This often provides a quicker way to run scripts and perform repetitive tasks. We'll use the argparse module, which provides a way to parse command line options and arguments. This code snippet demonstrates creating a basic CLI tool that greets the user. First, we import the argparse module, which is crucial for parsing command line arguments. We create an argument parser object and use the addArgument method to specify that our script accepts a -name option, which is a string. The args equals parser.parseArgs line parses the arguments given by the user at the command line. If the user provides a name using the ~name option, our script greets them personally. Otherwise, it outputs hello world. This is a fundamental pattern for building CLI tools in Python, allowing for versatile and user-interactive scripts. Packaging and distributing Python scripts. Packaging and distributing Python scripts allows you to share your code with other users and developers easily. This involves organizing your code in a way that others can install and use it with minimal effort. The most common way to distribute Python packages is through PyPI, the Python package index, using tools like setup tools and twine. This code snippet is an example setup.py file, which is critical for packaging Python projects. The setup function is imported from setup tools and is used to define the properties of your package, such as its name and version. The findGore_packages function automatically detects packages in your project. The install requires list defines third-party dependencies that need to be installed for your package to work. Finally, the entry points section allows your package to automatically create executable commands for your scripts, making it easier for users to run your software directly from the command line after installation. Concurrency with threading and multiprocessing. Concurrency in Python can be achieved through threading and multiprocessing. Threading is used for I/O-bound tasks, where the program waits for external events, such as file reading, writing, or network operations. Multiprocessing is used for CPU-bound tasks that require heavy CPU usage and computation. It allows parallel execution of code across multiple CPU cores. In the provided code, two methods of concurrency, threading and multiprocessing, are demonstrated using a simple function, print numbers, that prints numbers from 0 to 4. The threading part creates a thread and starts it, executing the target function concurrently with the main program. Once started, thread.join is called to ensure the main program waits for the thread to complete. The multiprocessing part similarly creates a process, starts it, and then joins it. This allows print numbers to execute in a separate process, potentially on a separate CPU core, making it suitable for CPU-intensive tasks. Working with asynchronous programming, asyncio. Asynchronous programming allows you to write code that can perform multiple operations at the same time, making it especially useful for I/O-bound and high-level structured network code. Using the asyncio library in Python, we can write asynchronous routines that appear to run concurrently, thus making our applications more efficient and responsive. In this code, we define an asynchronous function named main using async_def. Inside this function, we first print hello, then pause the execution for 1 second with await asyncio.sleep1, allowing other tasks to run during this wait time, and finally print world. The asyncio.run main at the bottom is the command to execute the asynchronous function main. This demonstrates a basic structure of an asynchronous program, where await is used to hand control back to the event loop, allowing it to run other tasks while waiting. Introduction to Machine Learning for Task Automation. Machine learning, ML, is a subset of artificial intelligence that enables computers to learn from data without being explicitly programmed. In the context of task automation, ML can be leveraged to enhance the efficiency of processes, predict outcomes, and make intelligent decisions. Here, we'll introduce a simple machine learning example using Python's scikit-learn library to automate the task of predicting whether an email is spam or not. This Python code snippet demonstrates how to implement a basic machine learning model for spam detection. Initially, the multinomial NB algorithm from scikit-learn, a naive Bayes algorithm suitable for classification with discrete features, is imported alongside other necessary modules. Sample email texts are defined along with their labels, spam or not spam. The count vectorizer is used to convert the email texts into a matrix of token counts, transforming the textual data into numerical data that the ML model can process. The dataset is then split into training and test sets. The multinomial MB model is trained on the training set. Finally, the trained model makes predictions on the test set, and the model's accuracy is evaluated, demonstrating a simple but practical application of machine learning to automate the task of spam detection.